All right, you've made it to week 12 of MAT 205. Lots of things happening in week 12. So many things that almost didn't fit on one slide. So we have a lot of things, finding slope and writing equations. All right, we're going to start off with finding slope. Let's get this better here. Given the graph of a line in quadrant 1 that models a real-world situation. Okay. The sugar sweet company needs to transport sugar to the market. The graph below shows the transporting cost in dollars versus the weight of the sugar being transported in tons. Use the graph to answer these questions. Here's the two questions. What's the slope of the line? And how much does the cost increase for each ton of sugar being transported? Okay, when we think about slope of a line, be thinking about the letter M is used to denote slope. And it's always rise on the y-axis over run on the x-axis. So it's what's changing in the y over what's changing, or rate of change sometimes it's called, in the x-axis. Okay, let's take a good look at this graph here. I'm going to try to get this keyed in really closely here, so you can kind of see what's going on. Okay, so on our x-axis, we've got the weight of the sugar, and it's increasing. We can see 1, 2, 3, 4 in tons. And as the weight of the sugar increases, we can see that the cost goes from $0 up to 4,000 is also increasing. Okay, so when they ask us what's the slope of the line, slope is going to be equal to rise over run. What's happening on the y-axis over what's happening on the x-axis here. Okay, here's how you're going to calculate your slope, or if you want to just look at it like on a graph like we're looking at right now, this is how you're going to pinpoint a couple points on your line. So we know that this line hits right here on the y-axis at this point of 0 tons of sugar is going to cost, which kind of sounds weird. Like, I guess that would be, is that 1,600 right there, $1,600, which is kind of odd because if you have 0 tons of sugar, really, would you really be paying $1,600? Let's make that big. Okay. But that's definitely a point on the line. Then you can look for another point on the line. And I see right here is another point, and you can kind of pinpoint all of the places where this line kind of hits our grid. Okay, so I'm going to kind of just mark out my territory here. So when you're figuring slope, I always start at the lowest point. So I'm going to start at the lowest point that I can see visually. And then I'm going to count up. So I'm going to rise up, right? So I'm going to rise up on the y-axis. Here's the y-axis. And then I'm going to run to my next point right there. So I'm going to run on the x-axis. So what did I actually rise? Well, I went from 1,600 to 2,000. So what is the difference between 2,000 and 1,600? Well, $400. So that's what happened when I went up and I rose from this point up and over to hit the next point here. So you start here, your destination is here, but how do you get there? You got to go up and over. You could continue to go up and over, up 200, over. What's happening on the x-axis? Well, every time you bump over, you're going up 1 more ton. So I came up and over 1 ton. And you're going to keep doing that. Up 400, over a ton. Up 400, over a ton. That's going to continue to help you find places that hit perfectly on that line. So our slope is 400 over 1 ton. Okay. So what is the slope of the line? It's just 400. You don't have to write 400 over 1. Right. So it's just 400. So I don't think Alex is going to like it if you try to type in 400 over 1. So just go with 400. Then what does this mean? Well, how much does the cost increase for each ton of sugar being transported? Well, for every 1 ton that you increase, it's going to cost you another $400 to transport it. So 400. So let me give you another one to try. And so let's look at the next example here. Deborah makes house calls for, maybe she's a pediatrician or something, or she's a vet and she comes out to take care of your pets. For each visit, she is paid a base amount and makes additional money. So she's paid a base amount and makes additional money for every hour she works. The graph below shows her pay in dollars versus the number of hours she works. Use the graph to answer the questions. Okay, let's look closely at this graph here. What's happening? Well, on the x-axis, the number of hours that Deborah is working, looks like they have it graphed out. It's going up by 1 hour. And on the y-axis, her pay is increasing. And let's see if I can kind of get real close here. So you can kind of see it's going up 10, 20, 30, 40, 50, you know. So we're going to figure out how much does Deborah's pay increase for each hour she works? And what is the slope of the line? All right, so let's find some solid points here. It's always good to start kind of maybe at the lowest point that I see right there. And then you want to look for another solid point. Now you don't want to pick this one here because you'll notice it's between, on the x-axis, 0 and 1, right? So that's somewhere in a half. That's not a great point to pick. Let's keep going. All right, what about this point here? That's a perfect point right there. Notice it falls right at 1 comma, looks like $30 there. Oh, that's, excuse me, that's $50 there. Let's get a little closer. So I avoided this point here because it's in between 0 and 1, and I went right to here. Just like I would avoid probably that point there because it's between 1 and 2, but I would probably very happily take this point right there. So let's just calculate the slope first. I know they want the pay first, but let's calculate the slope. So we know to start here at this lowest point and to get to here, you would have to go up on the y-axis. Well, here you are at $30, 40, 50, you'd have to go up $20. So you would rise $20, and then you would hop over 1 hour. So the run is 1 hour. So we know that our slope is for every 1 hour that Deborah works, her pay increases by $20. So the slope is 20 over 1, which we could just call 20. Let's take a look here. How much does her pay increase for each hour worked? Well, we know it's going to be $20, right? And what is the slope of the line? It's just 20. You don't have to put 20 over 1, although technically that is correct. Just leave it at 20. Okay, let's take a look at what's next. The next concept is finding slope given the graph of a line on a grid. All right, let's see if we can zoom in on this graph. Here's a line. And we know slope is always rise over run. Okay, now I think the hint that I gave you in the last 2 slides was to start at the lowest point. Start at lowest point. And then your destination is going to be here. So if you start here, let's say you wake up here and you got to get to work here. Well, how do we get there? Well, you're going to go up 1, 2, 3, 4, 5, 6, 7. So you're going to rise up 7 units. And then you're going to turn left and you're going to go 1, 2. Well, when you turn left, we've gone in a negative direction. So that's going to make that a -2. So our rise is 7 over -2. And Alex, you'll just put a negative sign and then you'll put 7 over 2. It doesn't really matter. I guess it kind of doesn't really matter where the negative sign goes, because let's just say you were to go backwards and you were to start here and go here. Well, you would come down 1, 2, 3, 4, 5, 6, 7. So you're coming down -7, and then you're going to go over to the right, +2. So you could even see that as -7 over 2, right? So it doesn't really matter where the negative sign goes. I like to put it in front to show that the whole line is laying in a negative direction, right? So we know positive slopes look like this, negative slopes look like that. So hopefully that helps. Let's give you some to practice. I gave quite a few to practice in this video so that you could get real good at this. So find the slope of the line given the graph of a line. And I'm going to try to make this real big and so everybody can see. All right. So take a moment, pause the video, and figure out what the rise and the run might be. Okay, if you're back, I started here, and I know I start here, I need to get to work here. So I'm going to drive 1, 2, 3, 4, up 5, and I'm going to jump over positive 2. So hopefully you found your slope is 5 over 2. Try it again. All right. Take a moment, pause the video. Let me kind of make these a little bigger for you and see what your rise over run is. So you're on a rise on the y-axis and run on the x-axis. Okay, if you're back, let's see if we match answers. I'm going to start here, and then maybe I got a hot date here. All right, so I'm going to go up 1, 2, 3, 4, 5. So I came up positive 5, but now I'm turning left. So when I'm turning left, I'm going negative. So 1, 2, 3, 4, 5, 6. So I rise on the y-axis up 5. I turn left, negative 6. So in Alex, I might just put the negative sign in front of the whole fraction because we know this is a negative slope and it's 5 over 6. If you want to think about it as starting here and going here, let's work it that way. So I'm going to go down, so that's going to be negative. 1, 2, 3, 4, 5, down negative 5, over 1, 2, 3, 4, 5, 6, positive 6. So that would be, let's see here, negative 5. Oopsie, I'm off the paper. Over positive 6. They're all the same thing. All right. It's just that where the negative sign is kind of depending upon, did you go up and over or down and over? So Alex is probably going to want you to just make the whole fraction, the whole body, just make it negative. Because they're all the same thing. A positive divided by a negative is still a negative, you know, a negative divided by a positive is still a negative. So kind of just put the negative out front. That way it kind of tells everybody, you know, that that slope is negative. Let's do it again. All right, I'm going to start this lowest dot and I'm going to go to this top dot. A lot of jumping here. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go up 8 and I'm going to turn right. So that's positive. 1, 2, 3, 4, 5, 6. All right. So my rise was positive 8. My run was positive 6. So I'm 8 over 6. All right, let me double check that. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to turn right. 1, 2, 3, 4, 5, 6. Yes. Now, that is the slope. Some people might say they want you to reduce that. Well, we could cut 8.5 and call that 4, and we could cut 6.5 and call that 3. And that's totally fine. It should potentially, hopefully Alex will take either answer. You might be wondering, well, how does 4, 3 the same as 8, 6 when we're talking about slope? Well, let's think about this. What if I started here and I came up 4? So I came up 1, 2, 3, 4, and then I turn right 1, 2, 3. Well, guess what? I land right there. So that's definitely a point on the line. So either will work. I could either go from this point to that point or from this point to that point. You could even keep going if you wanted to. 1, 2, 3, 4, and over 1, 2, 3, 4 over 3. All right, so hopefully that helps with finding slope on the graph of a line. Now, you're not always going to be given a graph to look at. You may just be asked to find the slope given a couple points. Okay, so we're going to practice this. There's a formula to this. So here's how you find this. It's y2 minus y1 over x2 minus x sub 1. All right, looks like a complicated formula, but it's really not. Let's break it down. So here's your first set of coordinates. I'm going to call this X, Y, first set of coordinates. X, Y, second set of coordinates. So now I've labeled this XY, XY, 1, 1, 2, 2. I see you first. I see you, your second right there, your second. So now I know if I have my coordinates labeled, I can just pop them into my formula. Okay, so who's the second Y? Well, it's -3. The minus sign is part of the formula. Who's my first Y? It's 4. Okay. Who's my second X coordinate? It's 8. Minus sign is part of the formula. Who's my first X coordinate? It's 3. All right, let's break this down. -3 minus 4 is -7, and 8 minus 3 is 5, and there's your slope. And you may even put it into the computer as just the negative sign in front, and then 7/5. So think about a negative slope. If we were to actually graph this out in a piece of paper, which you can do, you would get the negative, it would look negative, and it would be 7/5. Let's practice this formula again. All right, find the slope of the line passing through these 2 points. So write your formula to find slope from 2 points. And let me write that out in words too. This is the formula to find slope from 2 points. Okay, pause the video and see how you do. All right, I'm going to label this X, Y, X, Y. I see you first, and you are the second set of coordinates. Okay, let's go for it. Lots of negatives in here. Let's try to be careful. So the second Y coordinate is 6. The minus sign is part of the formula. Y1 is -7. Down below, the second X coordinate is -3. The minus sign comes with, and the first X coordinate is -7. Okay, what happens when you have 2 negatives kind of touching each other? You're just going to make them into positives. So 6 plus 7 is going to be 13, and -3 plus 7 is going to be 4. And there's your slope. Could you put this on a piece of graph paper and then count it out? Yes. But this is sort of a quick and down and dirty, easy way to find the slope from 2 points without giving a graph. All right. Now they're asking us to graph a line. Let's back out here. Given its slope and y-intercept. Okay. So here's my trick. The first thing you want to do is graph this first. Graph the y-intercept first. That's your starting point. Then, second, you deal with the slope. Because slope is really directions, if you think about it. It's what's changing. It's rising and running. Okay, so let's do the easy part first. Let's find our y-intercept. So the y-intercept says it crosses the y-axis at 5. Well, let's go find that. So here's the y-axis, and here's 1, 2, 3, 4, 5. So there's we're going to call this your starting point here. Now your slope is 1/3. So let's put that over here. 1/3 is rise over run. So if we start here, we're going to rise up 1, and then we're rising up 1 because it's positive. And then we're going to turn right and run 3. So up 1 and over 1, 2, 3. And that's where your second point is going to be. And then you can connect your line. So I'm just going to use the back of my driver's license here to connect. So in ALEKS, of course, you'll have to use the little tool where you can plant your points and then connect it. So I could check this by saying, okay, I cross the y-axis at 5, and then I go up 1, and I turn right 1, 2, 3. So really, these are just directions, right? Let's say you wake up here and you got to get to work here. Well, you got to go north 1 block, and then you're going to turn east 3 blocks. Let's try another one. This one says, graph the line with the slope of -3/4, and it crosses the y-axis at 2. Okay. Where are you going to start? Right here. And then this is going to be second. This is your directions. Okay, so we're going to start at the y-axis at 2, right there. And then let's break this down. This -3/4, right? We know the 3 is your rise. We know the 4 is your run. But where does the negative sign go, right? We have to either put it up top or down below. Right now, I have it kind of written up top. And the problem, they have it out here. You're going to have to figure out what you want to do. So I'm going to put the negative sign down here in the basement. So this means I'm going to rise up +3, but then this means I'm going to turn left -4. Okay, so let's try that. Up 3, 1, 2, 3, left 4, 1, 2, 3, boom, 4. And I can connect that. Okay, so if you start here, you're going to rise 1, 2, 3, +3, turn left. So 1, 2, 3, 4, -4. Now, what if you had chosen to put the negative sign in the top and kept the positive sign in the bottom? That's totally fine too. Let's work it like that. This means you're going to rise. It just feels weird to rise down and then turn right. Okay, so here we go. Down, 1, 2, 3, turn right, 1, 2, 3, 4. Well, right there. So down, you're kind of rising, even though it's weird because I like to rise up instead of rise down. You can go down -3 and then shift right 4. Right, you're still going to end up on this line. So any way you want to do that, totally fine. All right, let's give you another one to practice. Oh, I guess I don't have another one to practice. We're going to move to the next concept. Find the slope of the line and the y-intercept of a line, given its equation in the form y = mx + b. Okay, if something's written in this format, then your m right here is your slope, and your b is your y-intercept. Okay, so your slope is always going to be that. It's called a coefficient. Coefficient. It's going to be whatever's in front of the x. In front of x. Your y-intercept is always going to be just some sort of number not attached to the x. Not attached to the x. Okay, so the practice one they give us is y = -9 - 5x. Well, this looks a little different than that, all right? But we can still break this down. In front of the x is a -5. In front of this x is m, the slope. So our slope is that -5. The y-intercept is what's not attached. So it's that -9. You can rewrite this if you want. You could rewrite this as y = put this first, -5x, this second, -9. You're totally allowed to rewrite it as long as you be careful to keep the signs with the proper placement here. So now this looks more like y = mx + b, right? You've got your -5, which is your coefficient in front of your x, that's your slope, and the -9 is your y-intercept. So you'll notice your y-intercept in the format, it has a positive sign, but it could also be negative because your y-intercept could either be up here, that's positive, or it could be down here in the negative. Hopefully that makes sense. All right, here's another one, similar. Find the slope and the y-intercept of a line given the equation y = mx + b. Okay, well, what's the slope? What's the y-intercept? Which is also called the b. Okay, remember the slope is always the coefficient in front of that x. So it's -1/5. The y-intercept is this number that's not attached to the x, -5/2. If you want to, you could rewrite this because it doesn't look like it's in y equals mx plus b format. It's because these are kind of flip-flopped. So rewrite it if you want as y equals -1/5 x minus 5/2. Now things kind of line up a little better. So if you need to do that, you're welcome to. Then you can pluck out your slope and your y-intercept. Okay, find the slope and the y-intercept of a line, given that it's written in what's called standard format. Find the y-intercept and the slope of the line. Okay, this is not written in y equals mxb format, which would be nice because the slope is here and the y-intercept is here. This is not written that way. So we're going to rewrite this from standard form, which is this, ax plus by equals c. We're going to rewrite it to y equals mx plus b form. So 6x plus y equals 5. We want it to look like y equals mx plus b. You'll notice in this format, the y is by itself, right? But here it's not. Look what's going on this side. It's got the 6x here. So you are allowed to algebraically move the 6x over here. So 6x minus 6x means that cancels. So you got your y, your equals. And then you can either choose to bring down the 5 or the -6x first. I'm going to bring down the -6x first because I want it to look just like my equation here, my format. And then I'm going to tack on the +5. So once you rewrite it, now you know that your slope is here and your y-intercept is here. So your slope is equal to -6. Your y-intercept is equal to 5. Hopefully they give us another practice problem. I think we got one more in this video, one more practice problem. And I know this is a lot of concepts coming at you. All right, so another one. Find the slope and y-intercept. Well, right now this is written in ax plus by equals c format. So we're going to rewrite it into y equals mx plus b. It's a horrible m. So that we can find our slope and our y-intercept. So let's bring down this equation. -5x minus 3y equals -12. We want it to just say y equals mx plus b. Right now, if you think about this side of the equation, to get y by itself, you're going to have to get rid of this -5x and the -3. Let's get rid of the -5x first. Let's bring him across to the other side of the equation. So a -5x plus 5x cancels. -3y comes down. You have your choice between bringing down the -12 and the 5x. I suggest bringing down whatever's with the x first, then tack whatever is not with the x second. We're trying to get y by itself, so more algebra is involved. Divide by -3 here, here, and here. Okay, that's going to leave us -3 divided by -3 goes away. Y is finally by itself. 5x divided by -3 is just -5/3 x. But -12 divided by -3 is +4. Well, guess what? We now have our slope. The slope is equal to -5/3. And your y-intercept is equal to 4 here. And keep in mind, this negative sign should really kind of just be in the front of the whole slope. Just keeping in mind that negative just means your slope is going to look that way. Okay, hopefully this video has helped. Thanks for hanging out. Bye.